Today's presentation will discuss PFAS resources and considerations for groundwater professionals, plus what we've accomplished and what we can do better in the remediation industry. With that, I'd like to introduce our presenters for today. We are pleased to have with us Avram Frankel, Managing Principal at Integral Consulting. Avram is a professional engineer, technical expert, and program manager with more than 30 years of experience on a wide range of commercial, industrial, municipal, state, and federal sites. A civil and environmental engineer licensed in California, Oregon, Washington, Colorado, and Georgia, Avram provides his clients with strategic management and technical analysis in support of due diligence, redevelopment, technology evaluation, site investigation, water treatment, remediation, and legal matters. He has also spent a large portion of his career addressing emerging contaminants, including hexavalent chromium, perchlorate, PFAS, and 1,2,3-trichloropropane. We're also pleased to have with us today Ryan Moore, PFAS Program Manager at REGENESIS. Ryan has over 20 years of experience as an environmental project manager and laboratory account executive relating to multimedia contaminated sites throughout the U.S. His experience is focused on site investigations of soil and groundwater contamination, corrective action, evaluations, operation and maintenance of remediation systems, large soil removal remedial projects, in situ groundwater and soil treatment, vapor intrusion assessments, environmental laboratory operations such as QC evaluations, data interpretations, and business development. All right, so that concludes our introduction. Now I will hand things over to Avram Frankel to get us started.
Dane, thanks a lot for the intro, and really appreciate REGENESIS inviting me to be on this panel with Ryan and share some thoughts. I've been around a little while, over 30 years in the remediation and water treatment industry, most of the time as a consultant, but I also did work in industry, and I've worked on the construction side of things as well. So a couple of years ago, NGWA asked me to be on a panel where we kind of did a look back with some other folks that have been around a while. You know, what's really been game changers and key drivers in the remediation world, and particularly the soil and groundwater remediation world, how have things evolved, what's working, maybe what could work better. So I'd like to offer some of that perspective. I hope that's helpful to folks on the call. And I think it's really appropriate given the challenge of PFAS that we're, and so much being talked about and written about with PFAS. And I think, there's some perspectives that we can have on that come from the history of our industry so far. So just a short list of game changers. Again, this is really focused on soil and groundwater remediation, and also the connection of groundwater remediation to water treatment and water supply. Obviously, the remediation world is bigger than that, and there are other people that can speak to some of the other topics, but I wanted to address these: remediation hydraulics, the evolution and application of direct push technologies, the continued evolution and application of enhanced Insitu reagents, the integration of remediation and water treatment. I don't think we necessarily talk about that enough, so I'd like to highlight that today. And then, some bigger picture stuff: funding sources, the role of insurance historically in our industry, what it might look like in the future, and litigation. I think it's something that often isn't talked about, but I want to address it because it does affect what we're doing in the remediation world. Also touch on advances in analytical chemistry over time, what I've seen that means for us, or what it might mean for the future, and then possibly some other forces at play more recently that could affect our world. Just getting into it, it's been over 15 years since Remediation Hydraulics was published by some of my former colleagues at Arcadis. And if people aren't familiar with this textbook, and much work that's happened since then, building off of it, I highly recommend reading this, absorbing it. This, was really a breakthrough effort. A lot of people were involved in it to really understand when the application of in situ reagents, what were we really doing hydraulically in the subsurface? And that wasn't really that well understood. I think people forget that. and all the lessons learned and all the hard work by so many people on so many projects to get a better handle on injection pressures, fracking conditions, non-fracking conditions, what is an appropriate volume, let alone dosing, to put in the ground to affect a certain remedial strategy. And this has continued to evolve. And again, still a lot of great work has been done since this, but this was a fundamental breakthrough effort. And I think it's important to acknowledge that. Again, I mean, if we go back, I'm going to sound like the old guy a lot on this talk, but when I started in this industry, we didn't have any direct push technologies. GeoProbe didn't exist, and other types of direct push drilling, let alone all these probes. Really, all there was cone penetrometer technology, and then there started to be an evolution of environmental applications from cone penetrometer technology. Fast forward to today, we have the HPT tool, we have Targast, we have all these MIP tools. We have all these sensors, and it continues to evolve. These applications of direct push technologies, and we're understanding their limitations better as well. But the ability to collect a lot of high quality data is a blessing compared to where we've been in the past. We can collect a lot of data for a lot less money than we used to. But I think the challenge that we have is finding the sweet spot with site scale and really cost efficiency. And I'm going to say this a couple times today during this little talk. There's some sites that are very, very well funded, let's say by the federal government, and we have the luxury of collecting a whole lot of data, frankly, whether it's needed or not, but at least that option is available. And then there's a lot of other sites, perhaps the world most of us live in, where there are limited budgets and we have to make really important decisions about efficiency with regard to data collection. Well, these tools help us make those decisions. And I think the challenge is finding that sweet spot of getting enough data to move the project forward, but with more focused budgets. So I'll leave it at that. I will say one more thing. I think, another thing that's advanced so much in the recent decades is data processing and interpretation. But I think what I'm seeing is the real art of this is taking advantage of all these direct push technologies, but still rolling them into the context of an overall conceptual site model that's dynamic and workable and moves a project forward. We've had, in addition to direct push technologies, we've had the development of Insitu Reagents. And too many to list here. I think there's been an incredible evolution. We didn't have this when I first started in the industry. We've had this incredible proliferation of technology companies like REGENESIS, and development of reagents to treat a whole range of contaminants, and this continues. And really what was a game changer is increased reagent longevity has been a total game changer. If you look at just enhanced reductive dechlorination, but there's other examples. In the old days, we would inject highly soluble reagents and have to re-inject them relatively frequently. And there were all kinds of biochemical issues associated with that. Now being able to use and inject reagents that last, slower release agents, has reduced the cost dramatically of implementing these remedies. And just another tool in the tool. It's really been a revolution. And again, there's been an expansion. I mean, just look at zero-valent iron and finally cracked the nut on having a soluble form of that to inject. And for years, that was something that was under development. So there's still advances being made. There's advances being made in combined reagent and delivery approaches. It's becoming more affordable to implement gridded approaches, whereas in the past on the larger sites, we had to take injection line approaches because that was really the more cost-effective approach. So it's just more tools in the toolbox, more options, because we have better injection options and we have better reagents. Sorting through all of that, it's still There's still a lot of work to do on every site to make the best choices there. But what is kind of hopeful, along with our understanding of remediation hydraulics, is there's just the increasing evolution, and I believe slowly over time, standardization of procedures for the application of in situ remedial approaches. The one thing I will say is scale is still a limitation. I mean, I think sometimes this gets glossed over, or there's certain biases in certain discussions. But scale really, we can do more at a bigger scale with in situ technologies. But depending on the funding, depending on stakeholder realities, there is a limit in scale. And I can say this from hardcore experience in terms of the application and the appropriateness of application of in situ technologies. And really, in many cases, is a massive in situ effort really the right choice versus a water management approach that perhaps can deliver potable water. And I'm going to talk about that a little bit more too. But I think there was a shift in our industry towards in situ and rightly so applications, but we sometimes forgot the lessons learned from the mega plumes and the really big sites where in situ applications the scale is not appropriate. It's great to have all these reagents. It's great to have these new drilling technologies, but we still have access issues. We still have issues getting to depth. I'm showing here a 30-ton cone rig in the bottom right that we used on a site in California recently. There's limitations, and there's still challenges. Even with our better understanding and evolving understanding of remediation hydraulics, it's still difficult to execute in situ projects in certain geologies. And that's where the challenge is. But the good news is that we've just got a huge library of knowledge. Moving forward here, I do want to talk about this because I don't think it necessarily gets talked about enough in our industry. Is when you get to the larger scale sites, when you think about sustainability issues, when you think about water supply, and I'll talk about this a little more, but emerging contaminants such as PFAS are shining a bright light on how do we do integrated remedies that provide finished water where it needs to be, whether it's for agriculture or for drinking water or commercial industrial applications, but also integrate a remedial component. And the reality is we're just going back to the future. In the early days of remediation, there were many, many massive pump and treat sites, and there were all kinds of issues with those. But one thing that was done at many sites, and we've advanced the ball on through time, through groundwater extraction and reinjection and focused groundwater extraction and reinjection, is there were quite a few large plumes that were ultimately remediated and provided a lot of water supply in the process. And we're seeing a return to that. I can think of some major projects in Southern California. I can think of projects I'm involved in. I can think of litigation around these issues. But I really believe that we need to move back towards and more aggressively towards integrated groundwater approaches that link remediation with supply, especially in times of drought, which we're seeing more and more of with climate change. So I'll get off my soapbox and talk a little bit more. I do think it's important in the remediation world that we do, again, keep drinking water supply close to our hearts, because we're going to see more and more integration here. But I do want to highlight that the answer isn't always treatment. When you look at some of the biggest water supply issues around PFAS, it's really important to remember the word mitigation and mitigation alternatives. Personally, I'm very involved in this, and I know other folks are too, but it's really getting us into the realm of water supply, where we look at alternate sources, where we look at the replacement and retirement of supply wells, deepening of supply wells, refurbishment of supply wells, alternate supply wells, sometimes treatment, sometimes a blend of treatment and alternate sources, and blending, which is done all the time in the water supply world to deal with various constituents of concern. So these are all tried and true tools in the toolbox, and I just want to make a plug for remembering how much we've learned about these things and how much they can be applied in the drinking water treatment world, but also in the remediation world as a part of integrated remedies. Let's talk about kind of funding sources and non-technical things. Whether folks realize it or not, I know many people do, and I know personally, so many major big projects that I worked on over my career and still work on have been funded by general liability policies. These are old policies that companies had to take care of general liability and environmental contamination, to speak plainly, fell under, you could claim the costs and get funding for remediation. And that was a big driver. It still is a big driver in our industry, whether people realize it or not. But over time, I mean, even before I started in the late 80s, those policies were being rewritten in a way that excluded these broad terms that allowed claims to be made for pollution. And it's been 30 years or so, and some of these policies are maxing out, some have expired. You've got the newer policies out there. So the funding, this general liability is a funding source, let alone other insurance products related to cost cap insurance and things of that nature, which have largely, almost entirely gone away, that funded a lot of work as well. This source of funding is less than it used to be. What will it look like in the future? I think it's kind of a game changer. There will have to be other sources of funding. And when you look at PFAS, that's almost being entirely written out of these policies because the insurers have learned. So just something to be aware of. I want to touch on other funding sources too, and I think that there's been a lot of people are very involved with Department of Defense work, Department of Energy work, CERTA, ESTCP, EPA funding sources. This has been going on for a very long time, and it's such an important part of our industry and how things have evolved. When we talk about circular and RCRA sites, we talk about federal funding on those sites. There's been so much money spent, so many lessons learned, so much technology development happens in this space. And, I think that it's whether these were efficient cleanups or not, the good news from all of that is that the industry has leveraged the results of those efforts to develop new technologies, to share knowledge, and it's been a very successful model in that respect. I mean, there have been some downsides. Some people would say that there's been very conservative processes and approaches on these kind of sites, and maybe we're slow and not cost effective. But I think it's important to have the broader viewpoint of collaboration between, especially on the federal side, public sector funding and technology development and sharing, and how that relates to private investment in private technology companies, and how that knowledge just comes out into the marketplace and evolves and gets used on non-federal sites. And I think it's a really good story here if we kind of look back over the last 30 years. There's been some evolutions that I think are kind of interesting. Connecticut, you're starting to see that on the state side of things, where there's been long-standing underground storage tank cleanup funds, which also have made a huge difference in our industry in terms of actually cleaning the sites up. We now see this evolution in Connecticut, and we have it in California too, of funding for non-petroleum contaminants, particularly chlorinated solvents. But Connecticut has one for dry cleaners. There's some other states that do too. This new sub-account program, the SCAP program in California, is a game changer. There are sites, and I'm involved in a number, and I know many of you on this call are too, where this is not the federal model. This is very specific money for very specific scopes of work that the state is funding, and it's cleaning up a lot of abandoned sites, a lot of sites where the site owners didn't have funding, and it's really moving the needle on cleanup. And sometimes we're able to try new technologies, new approaches in the process. So it's really positive. And I hope we see more of that. I do think it's important to touch on litigation. I know some of you are very involved in the consulting side of our business with regard to litigation. Others are not. I hadn't been until maybe the last 10 years personally more involved in this kind of thing, but it's a big driver. The resolution of these claims, no matter what one might think about the merits of a given claim or the nature of it. And there are a lot of issues there to discuss, perhaps in another talk. We do have the resolution of these claims does drive new work in our industry. A lot of it is on the water treatment side, but over time, a lot of it has been on the remediation side. It only seems to be increasing with regard to PFAS and with regard to emerging contaminants, but it's just something to be aware of that you may not be aware of. Some of the projects that you're working on are actually being funded by resolved litigation. So it's a major market for us. Do you want to talk about advances in analytical chemistry? I think it's easy to forget what things were like 30 years ago, even 20 years ago. In general, I think it's safe to say, and most people would agree, that advances in analytical chemistry, that is lower detection and quantitation limits, have helped us in the sense that, you're not in a good position if you have a regulatory standard to meet and you can't reliably measure to that standard, or really below that standard, so that you can stay ahead, you can be compliant and stay ahead on compliance. So that wasn't always the case 30 years ago, 25 years ago. Now it's kind of swung the other way, where we have great tools that really help with compliance situations and site evaluation, so that we can develop risk-based cleanup goals, or at least have a discussion about that. We're now in a realm where, it's possible, and some people have argued that we've advanced so far in analytical chemistry that we're getting, that it's driving regulatory criteria and driving, when we're in the parts per quadrillion, like this new PHGs that have been proposed by California for PFOA and PFOS, where we're getting such a low limits. What is the balance now between reporting limits, development of regulatory criteria, politics, economics, as it relates to the evaluation of health and environmental effects, and setting of regulatory criteria? And there's a lot being written on this. So I do encourage people to be engaged on this topic, especially with regard to PFAS. So some good things to remember, because I think it's easy to get caught up in our work and our various projects and not realize how many things are going on and how much we've learned as a community in the remediation world. The development of high resolution delineation and the tools associated with that has been a wonderful thing. But again, efficiency, making what's the most efficient way to apply them is something to think about. Plume evolution, a lot's been written on plume evolution. Where, is it an old plume, is it a young plume, time of release, how does that relate to remediation? I encourage people to really be on top of that, recognize what the status of the plume is when you are working on a particular site, because there's still mistakes made in that realm. The development of dynamic CSMs with all the tools available for that, to really understand sites, and of course all these things start to relate to each other. The use of combined remedies, multiple technologies, different approaches. This has been a huge evolution in our industry. There's a lot of lessons that we've learned from the remediation of large plumes. I think sometimes those get forgotten. So again, a lot's been written on that, so I encourage people to dig in on that topic. I talked a little about financial, insurance, legal realities. Those are often in the background bracketing what we're doing. And I'll just make two other broader statements here. I fear that we're forgetting lessons learned around life cycle cost evaluations. I've had some recent experiences where there was almost people arguing against the validity of life cycle cost evaluations, or looking at things in a really a manner that wasn't comprehensive from a funding and decision point standpoint, where we really factoring in costs over time and all of the costs. That's always been an issue in our industry, and I think it continues to be a challenge. And then there's the issue of scale. Are we dealing with a small site, medium site, large site? That can really change how we look at things, options available to us. what's cost effective and appropriate and what's not. So just some things to think about. And I'll just throw this in here, and then I'm going to run through about 6 slides on PFAS and then hand things over to Ryan. We're hearing a lot about ESG criteria, environment, social governance. I'm not going to say a lot about this other than things are evolving, and there's some questions being raised. Will spending habits adjust in a changing world towards truly sustainable projects? What is sustainable? Will we see some, we're already seeing some changes here, but will we see a lot of changes towards climate change driven spending versus, a lot of what we've seen in the past is cleaning up, a lot of cases, low threat anthropogenic chemicals in the environment. Will there be a shift in priority due to climate change? I think sometimes we think there's infinite funding available for our industry, but will there be a refocusing around drinking water mitigation? Will there be a refocusing around what truly is reducing risk? We've been talking about this stuff for decades. Hasn't really happened yet, but I am concerned about it with regard to PFAS and other emerging contaminants that, are we making the mistakes of the past and maybe not focusing our resources as well as we could have? It's something to think about, and I think ESG and other related topics could be other forces that help that change how funding occurs. Let's shift gears to PFAS, and I know I'm taking up a lot of time here, so I want to just address a few things. We hear a lot about the evolution of PFAS regulatory criteria. I'm going to look at just drinking water here. There's also groundwater protection, of course, and surface water. Integral is, I see a lot of misinformation here. It's tough to keep up in some cases. The reality is things aren't evolving that fast. They are evolving, but these are the states that have any kind of drinking water criteria, whether they're guidance or enforceable. It takes a long time to implement enforceable regulations in most states. Most states are not regulating PFAS and don't plan to, regardless of what maybe you've read or heard. But there is evolution, and it's important to pay attention to it. Integral is preparing some interactive maps that will be on our website in the next couple of months for groundwater, surface water, and drinking water, just because I think there's a lot of misinformation on this, and it's important that we're all on the same page when we have these discussions. Here's the actual enforceable drinking water standards in the United States right now. The ones in Washington are proposed. Wisconsin just moved from saying, hey, we're going to regulate 2 to 4, but they still haven't figured out what those are, but the intent is to do it. But these are mostly long chain PFAS, and you can read up on resources to understand the difference between long chain and short chain PFAS, but there are some short chain PFAS in here. But anyway, it's important to sometimes to just see it all in one place where we are. What's going on with this? Some states have chosen, and again, I'm just going to focus on drinking water here because I think it's representative. Some states have taken an individual. We're going to look at each compound. We're going to assess the risks individually. And then we have some states that are regulating PFAS as a class. And there's a lot that's been written on this, and I encourage people to get learned up on this. It's a really different mindset and approach being taken by regulators. And in Colorado, in their surface water regulation, which is what they have right now, it's a mix. It's really interesting. It's actually an interesting regulation to read. But I'm just trying to increase awareness here. There's a lot still being sorted out here. Just looking at short chain PFAS too, because there's been a lot of conversation about short chain PFAS. I recently did this for a project, just looking what is for PFBS, PFBA, GenX. These are the PFAS that are being regulated with enforceable drinking water regulations in the U.S. right now. Just look at the range in some of these. Look at the range for PFBS. Look at the range for GenX. Look at the range just in general, and then so it's what this represents. There's a lot of conversation on this subset. These large ranges reflect different interpretations of risk between short and long chains, and also just within the short chain subset. There's a lot of discussion and concern about this, but I really think it's worth asking the question: how many projects are really going to be driven by short chains, and is there going to be a consensus that's built around PFAS in general, but the short chains in particular? I was recently working on a project where the client was making a big deal about, there's basically fear about short chain PFAS in the water supply. But when we actually looked at the data, none of the short chain PFAS that were there, and there was maybe 3 or 4, were anywhere near these any proposed limit that's out there right now. So it was a good educational moment, I think, for everybody on the team. I know it might be uncouth, but I'm gonna suggest reading the own paper that I published recently. I wrote this paper for people that want to just get up to speed and have some perspective on PFAS. I was asked to do this by Groundwater. There's just so much information out there, so I was just trying to be helpful. This addresses regulation, risk consideration, relative risk consideration between contaminants, comparisons to other COCs, mitigation, appropriate risk reduction, and most importantly, it's a compendium of so many other people's great work in the references that I steer folks to just get up to speed and begin to ask their own questions with regard. In the end of the day, I firmly believe we can meet the challenge of PFAS. We've met it for so many other contaminants, but we could use some more practically applicable in and ex situ technologies on the table that address a range of site scales. Lots of progress has already been made. We have some challenges with residuals management, but we had those same challenges with dioxin and PCBs. So again, a lot to be hopeful about in terms of addressing PFAS. I think the concern by me and others is that we'll just repeat some of the mistakes of the past, which is maybe not focusing our resources and not doing risk-based remediation. I do want to steer towards this paper too by Charles Newell. It really gets at some of these questions of comparing relative risk. And again, we've been here before with other contaminants, and I'm very hopeful about our progress with PFAS. And I want to hand it on. I'm done here, and I thank you, and I want to hand over to Ryan. Thank you.
Yeah, thank you, Avram. Appreciate that detailed information. It really goes well with what we're going to be talking about. This is Ryan Moore. I am the Great Lakes Senior Technical Manager and REGENESIS PFAS Program Manager. I'm based in Northwest Indiana, just outside Chicago. Today, I'm going to talk a little bit about our plume stop technology and how you can utilize the plume stop technology to be a cost-effective approach to mitigating PFAS risk. Kind of like you just heard, there are a lot of challenges when dealing with PFAS, and I kind of put some in a non-technical and a technical kind of basket where, the non-technical are very important, and sometimes I think have created this awareness of PFAS much more so than other contaminants. You have a lot of grassroots organizations out there who are maybe, living within a PFAS plume, or find out that their water wells contain PFAS. They become involved, and these organizations, through social media and other means, develop and become very vocal in their specific issues going on in their environment. Movies such as the Dark Waters movies or the documentary The Devil We Know, have come out in recent years and highlight some of those same challenges that these people are facing. Some of the other, issues is like what you just heard, the legal liability and having an understanding of like who's responsible and who's going to pay for those is real important to understand for every PFAS project that we work on. You've also got the technical side. As just highlighted, there are many states that have regulations or an actual, action levels that you would have to adhere to, but then many states you do not. You've got advisory limits with the federal side, and that there's talk that some may become more regulated over time, but there's this kind of hodgepodge of regulations that you have to adhere to. So you really got to understand what state you're in or what that specific scenario. One of the things too, in my experience, in the last 4 or 5 years we've been dealing with PFAS, is that it's not just a PFAS plume that you're dealing with, and in many cases it's commingled with something else, and we've got several projects where there were petroleum sites where you know, they either had a fire training facility on site or had a fire where foam was used, and now you've not only got you know diesel range contaminants, but then you have the the firefighting foam compounds as well. PFAS is resistant to conventional treatment. We all know that. It's not breaking down in the environment. That's why it's called the forever chemicals. You're not going out and doing a chemical oxidation and source treatment. It's just not going to work. And so that gives you another challenge of how do you address that. And then the end goal. What is the end goal, right? And what we're seeing is that in most cases, it's low parts per trillion. That's a very, very small number. So kind of along the same lines here on PFAS challenge, you know, what we've noticed is that in many cases, people are trying to address PFAS plumes with pump and treat. And pump and treat is a great technology when you're looking for mass reduction, you know, source area kind of removal. But when you're trying to address a plume that, you know, is 1,000 feet long or migrating through multiple townships or multiple properties, it's really difficult to install a pump and treat system to capture everything that, you know, could be at risk from the PFAS. You know, pump and treat requires large scale infrastructure and capital costs up front to install, but then also to maintain. You know, we've all had those project sites that we worked on where this pump and treat's been running for years and there's no end sight, right? And actually you come up to the, you know, the end of the equipment life cycle and you have to replace it all. So there's continued cost over time. Additionally, pump and treat's going to generate a waste stream. You know, technology's gotten better to try to reduce that waste stream. And it seems like a lot of it's just more concentrated and then becomes a little more difficult to get rid of. And as if, you know, as if the federal regulations develop, you know, these compounds could be listed hazardous waste, which makes it even more difficult to address. So, you know, what if you had something that can give you a substantial cost savings over a pump and treat, eliminate the need or the eliminate the waste stream being produced, and an overall greener approach? So these are some of the questions that we've kind of looked at, and why we want to utilize the plume stop technology as our solution to address those scenarios. And the goal, you know, with a plume stop, most plume stop projects when we're using it to treat PFAS is to install a series of plume stop kind of filter zones. So as groundwater passes through these filter zones, it becomes clean. And then on the downside, we, you know, prevent that migration of the PFAS compounds. So what is plume stop? So plume stop, or liquid activated carbon, as we call it, is activated carbon that's been processed and milled down to the size of 1 or 2 microns. Super small, that's the size of red blood cells. That carbon is then suspended as a colloid in a polymer solution. We'll take that product, we'll ship it to the site, and then we'll mix it with appropriate amount of water and we eject it on site, and it injects very widely under low pressure. In essence, what we're trying to do is create a underground purifying filter within the aquifer. The goal for any plume stop project, not just for PFAS, but if we're doing it for benzene or chlorinated solvents, is that we want to apply it in situ within the same zones that the groundwater is passing through. And the picture shows here is that we want to get and intercept that contaminant plume with the plume stop technology. It does a few things. It prevents the continued migration of that contaminant, but then we also protect against back diffusion over time, either from above or below our treatment zone. And again, this is our goal for every plume stop project that we work on. So, you know, with PFAS specifically, what are we trying to do? You know, the goal is to eliminate the risk of the PFAS to the receptor, and that receptor could be a stream, a drinking water well, you know, just maybe migration off-site, you know, to the neighboring property. So, you know, what is the risk? Well, it's the hazard times the exposure. And if plume stop can bind up that PFAS in situ, we've eliminated the exposure down gradient, therefore we've eliminated the risk. And that's real important. Again, the number one goal is we want to eliminate risk of the PFAS to the receptor. Again, it could be just moving off site, or drinking water well, surface body, surface water body, etc. When we look at plume stop projects and we do our design process, I'm just going to kind of talk real quickly about our modeling. And it's real important because, you know, I get the question a lot, Ryan, you know, how do you know, or how long is this treatment going to work? Well, you know, there's some third-party research out there that I can share with you after the call, or, you know, reach out to me. We can get that into you. But also internally, we have a program that we've developed over years now called Plume Force, and it's a long-term prediction model. And, you know, this graph that you're seeing is kind of a graphical output of this model. And within the model, you'll have compound-specific isotherms that are inserted. You'll have competitive absorption between species. That's kind of what the graph is showing here, where the longer chain compounds will be will outcompete the shorter chains, and so they'll be pulled out of solution first. And then as you move, as the, you know, the groundwater plume moves through the contaminant barrier, it will pull out additional contaminants. And so, you know, you can make that barrier longer based upon the suite of compounds you're trying to address. Again, I said it was, you know, the models that we're running, we could do, you know, VOCs, but then also a variety of the PFAS compounds that we're routinely addressing. Within the model itself, you know, we are putting site-specific information, and this is where some of that high-res characterization is very important, because we can get, you know, the, you know, soil porosity or different soil types can go in, calculated seepage velocities, you know, we can, that'll be input in the model. Variations both vertically and horizontally within the barrier placement, so we can make multiple model runs to demonstrate, you know, either multiple treatment lines or to demonstrate changes in the geology. And then we also look at carbon demand. You know, carbon demand not just with the target compounds, but on anything that may have affinity to activated carbon. So I mentioned that the many of the sites we work on are commingled with other contaminants, and so if you had, say, TCE in the mix, we would add TCE to the model run and not only account for that effect within the plume stop barrier, but then maybe also account for dechlorination over time. Maybe we've added an enhancement, you know, electron donor to the barrier to degrade the chlorinated solvent, but then obviously the PFAS won't degrade. So, you know, within our model runs, we can account for all these different variables. Overall, you know, you come to me and say, Ryan, I've got a project site, I want REGENESIS to look at it. You know, what does that look like to us, or how does that process typically unfold? And it usually starts out, we'll ask for the information that you have on your site, you know, site maps, cross sections, the data. We'll do initial review and maybe come up with some initial concepts, and then we'll sit down with you afterwards and say, okay, you know, we looked at your site, you know, we think we've got a good solution. We think plume stop is absolutely what you need here. However, you know, we've got to do some additional testing or design verification testing to confirm some of the assumptions in the model and our design process. And a lot that design verification testing, you know, is a wide range of steps. It could be just going out with a high-res characterization rig, the HBT, MIPS, you know, etc. You know, maybe we're doing an injection test to try to confirm ROIs with each injection point before you ramp up for a full-scale application. And then we'll go out and we'll do the final design. And that final design process is in coordination with the consultant. So it's not just REGENESIS doing this on our own in a black box. You know, we're very transparent about it. We want to work with you and, you know, have you in the process with us, because no one knows a site better than you do. You know, we're coming into these many times years after you've been working on a project site. So you've got a lot of knowledge, and we want to really integrate that knowledge into the process. And then finally, we'll actually go out and do the installations of the plume stop filter zones or the PRBs or whatever that design may look like through our REGENESIS Remediation Services group. For PFAS specifically, you know, plume stop has been very successful. We've got dozens of sites in the ground and performing. We've got hundreds of sites that worldwide that we are looking at and implementing designs and kind of working through the approval process. As you guys know, a lot of these projects take years to develop and to actually go into ground, and PFAS is no different, especially with some of the states where they're, thinking about changing regulations, or they just recently got a new regulation, and it takes time for people to kind of work through what does it mean, or what do they have to do to mitigate risk at their sites. But when they get to that point, plume stop has been a very popular approach for a lot of reasons, and I'll kind of talk about that more in a second. But just again, it's been widely accepted across the globe. The type of project sites, mostly, we're doing everything from airports to manufacturing facilities to EPA funded sites and DoD sites as well. Kind of go into the key benefits of why you'd want to use plume stop. It's a topic for another presentation, but we have found that the plume stop approach is significantly lower cost when compared to a pump and treat system. Kind of that life cycle cost or life cycle look at your project. You're going to see very rapid results, weeks to months, to get significant reductions. Again, the plume stop technology, it's been around for 6 or 7 years now. It's widely accepted by both state and federal agencies. It's sustainable. Again, there's no ongoing pumping. There's no weekly or monthly O&M. We're not generating waste. So from that standpoint, it's a very green technology. And there's also could be a warranty involved. And then I got this kind of ... What does a warranty mean? I want to introduce you to Plume Shield, and I know this has been talked about a little bit before, but Plume Shield is a new system that we are developing and rolling out through REGENESIS. And in essence, what Plume Shield is a program for your project, for your PFAS site, where we'll use the plume stop technology again to create these different filter zones in situ to eliminate the risk. It's backed by a standard warranty, and there's options for extended warranty as well. There's little financial risk to the stakeholders, and the reason why is that we're not going to require payment until the system is performing as designed. And that's some very important stuff. So, we're going to put our money where our mouths are, and we feel very confident with Plume Shield and the plume stop technology that we can go out and offer this type of program. There'll be more more will be discussed about this program in the near future, but I just kind of wanted to trickle a little bit more details out for you now. And with that, I'm going to end my section, and I want to thank you guys for joining us, and thank you, Avram, for your presentation as well.
All right, thank you, Ryan. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple of quick reminders. First, you'll receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you'll receive a link to the recording as soon as it is available. All right, so let's circle back to the questions here. We have a question here for Avram, and it is, where do you feel the real innovation is coming from in the remediation industry?
Well, I think there's certainly in the development of new reagents. Ryan was just talking about plume stop, but I think that's one example. There's others. There's a lot of innovation there. There's still innovation, I think, in the drilling world and application world. How we get stuff in the ground. I think we're going to see some really good innovation in terms of residuals management with regard to PFAS, over the next 5 years as well. So, and then I think that, the big overarching one is in data management and how we process, collect data, and subject for another webinar, I imagine.
Okay, thanks, Avram. So here's another question. This one's for Ryan. Ryan, the question is, what happens when the colloidal activated carbon becomes saturated over time?
Yeah, it's a great question. When we do a design or kind of implement the project, we leave room where if you have to, in year 15 and year 20, to come back and reapply. So part of the program, you may have a well network or some sentinel wells. So if you see something that may break through, then you just come back and reapply, within the downgrading or close proximity area that we would be injecting. We also think that over time, with the further research that's being done, is that hopefully there'll be another technology that we could co-apply with the plume stop to actually degrade these contaminants in situ. So.
All right, thanks, Ryan. So here's another question. This one's for Avram. This one is, simply put, what could we be doing better?
Well, I think there's just sort of the ongoing. I think Ryan hit on some of it in his talk. Is really coming up with, given all the tools we have, really doing true life cycle cost evaluations where our clients are asking us to do that. Some clients have a more short-term perspective, but the majority really want to look at true life cycle cost, and that could involve looking at a lot of different remedial options and approaches and appropriately comparing them. So I'd still highly encourage that.
All right, thanks, Avram. So here's another question. This one's for Ryan. And Ryan, the question is, has plume stop been accepted by regulators to treat PFAS?
It has. I can't think of any location or any state where we have applied it where the consultant has worked with their partner at the whatever agencies that they're dealing with, and we've not gotten it approved. Just like anything that you would inject into the ground, they have questions, they want to understand the process. And REGENESIS is here to help you with that. Myself and other individual managers, that's what we're here to do, is to walk you through the process and to provide and be transparent with information to all stakeholders. And so we had a lot of questions related to plume stop near waterways, and so we've gone through extensive research on that end and provided information for clients to address, and how do we keep it out of the waterway if you're near a waterway. So yeah, it's been very accepted. They just want to know information, and as long as you're transparent and really share them the details, then they've been very accepting, and I haven't had any problems with it being approved.
Okay, great. Thanks, Ryan. So here's another question. This one's for Avram. And the question is, what are your thoughts on PFAS regulation and the implications for site remediation and drinking water supply?
Yeah, I think this is where really keeping tabs on, like Ryan was talking about risk reduction in the beginning of his presentation. I think there's really just this, remember, a lot of states are not regulating PFAS at all. And we have this federal PFOA, PFOS guidance value that is, could be potentially applied in other states, even though it's not enforceable. I mean, I guess what I'm trying to say is this PFAS regulation is evolving, but it's still pretty Spartan. So, you know, that's the thing, and I highlighted in my paper, I talk about this a lot, is just the lack of consensus around PFAS regulation. So hopefully over time that will resolve itself to something that's coherent and consistent. I'm not saying that it will, but that would be the hope. And then, you know, then it makes it easier for us to do our jobs in terms of answering our clients' needs with regard to PFAS. Because right now it's hard to define what that risk is that needs to be resolved. So that's the nature of dealing with emerging contaminants. But that's I think those are the things to pay attention to right now.
Thank you very much, Avram. So here's another question. This one's for Ryan. And Ryan, the question is, does the source of the PFAS have to be removed in order for a plume stop barrier to be effective?
Short answer is no, it doesn't. The long answer is that, you know, anything you can do to reduce the flux coming into your plume stop treatment would just add to the longevity of the barrier itself. So if someone's got say a former fire training area that they're going to demolish, and you know they're going to remove soil or remove the the former pad or whatever that may be in, then you would expect that over time that contaminant flux coming into our treatment zone would go down over time. So when we do our designs, we're looking at it as more of an infinite source, and so we're trying to look at the worst case scenario. But yeah, so it doesn't have to be pulled out, but it would be good if you did as well. So.
Okay, so here's a question for Avram, and it is, where do you see the PFAS regulations heading with the new federal administration?
Yeah, that's a tough one. I think that's a question on a lot of people's mind, and of course, there's a lot of interest in this from many different stakeholder groups. I mean, the EPA has signaled in the last administration and now into this administration the intention of developing an MCL for PFOA and for PFOS. So I don't think I'm like making any major prediction there, but that's really all I think I would feel comfortable about talking about. I do think it's important that people, and again, I address this in the paper that I published, you know, looking at EPA's action plan, and the new administration is following up on that. So there are specific action items in there, including the various toxicity studies on other PFAS COCs. And as those move forward and are completed, I think that's the thing to look at with regard to potential future PFAS rates. So just to add, it's just will PFOA and PFOS be listed as hazardous substances under CERCLA? And it looks like that will happen, but I think when is anybody's guess.
All right, thanks, Avram. So we do have another question here. This one's for Ryan. The question is, how do you address competing contaminants when using plume stop to treat PFAS?
Yeah, it's a good question. You know, kind of back to the slide I had up related to our modeling process and the graphical output. You know, we want to identify any species, target or non-target compounds that may have affinity to activated carbon. And then on top of that, we do have some safety factors embedded within the software to account for unknowns. And so, we want to account for what might be coming in and overcome what might be coming in to still achieve the goals of the project. And so, the examples, if it's commingled with, say, benzene, we're not going to look at just benzene as the compound, but we may look at more of a broader approach and do like a TPH scan to find out, what other hydrocarbons may exhibit a demand on the carbon in conjunction with the PFAS compounds that we're looking at. So yeah, a good question. It's something that we look at every project site, and that's a lot of times part of our DVT process. We may have some requirements for additional sampling, maybe it's some compounds that you don't normally run, but they're could be there, and again, this isn't for a regulatory standpoint. It's not, we're not trying to get you to achieve some specific goal with those other compounds. It's just, how do we understand the flux coming in to the barrier and how it may affect performance. So yeah, good question.
All right, thanks, Ryan. So we have another question here, and this one's for Avram. And the question is, do you have any overall thoughts on where we are with PFAS remediation technologies?
Well, I mean, if we look at the water treatment side, I'm going to include that in this discussion. I mean, there's been a lot of work and progress and we have some, GAC ion exchange, in particular, a lot of progress and real world applications to treat a range of PFAS. So there's a lot of good news there. Ryan just talked about the plume stop applications that are ongoing. I'm looking at that in some cases as well. But we, as far as in situ remedy, and again, I'd emphasize scale being really important in those considerations. There's some other things out there too that help with mass reduction, ex situ treatments like foam fractionation. Again, it has its place, it has its role as maybe a part, one unit process of many in a treatment train. But we could use some more tools, and there's a lot of research going on in academia. You can go to conferences and listen to endless papers about research in academia. I think the challenge that we're in is how many of those translate to practical real world technologies, and that is going to be a big sifting function. I think as harsh as one as we've seen, and that'll be in the for PFAS, but of course some good will come out of that and some new technologies. Again, we have some powerful tools available to us, but we do need more. And thankfully, there's a lot of investment in that realm.
All right, well, thank you very much, Avram. That is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about services from Integral Consulting, please visit integral-corp.com. If you'd like to learn more about remediation solutions from REGENESIS, please visit regenesis.com. Thanks again very much to Avram Frankel and Ryan Moore, and thanks to everyone who could join us. Have a great day.